What's going on, everybody? Today we're going to take a shot of a kudu and run over what's going on with the bar and graph. So this is going to be the shot, this kudu right here. And we're going to show exactly how they get the numbers for the graph down at the bottom and what it represents, and exactly what the numbers are at the top and how they really aren't related to the graph at the bottom other than penetration. Penetration's a constant because, like, sticking a stick through somebody or shooting a stick at somebody, it's a diameter, and that's what it's going to be. All right, we're going to zoom into the bar graph here, and we're going to look at the data that I got. So this is a spreadsheet that I used. I got the data from the end game, and I put it into a spreadsheet. So we're going to look at the 34.46 and the energy loss 43.38. So that's the energy loss is what's going to be deducted from the flesh to the bone. So this is the first hit. It's got the 30.46 and the 438 energy lost. So this is actually coming from in the game when you shoot an animal. So we're going to move this over and we're going to subtract it. So 438 minus 30.46 is the 2608. So we're going to zoom this down until it hits the bone, and that should hit at 2608. I'm going to try to do this a little bit faster, but there's the point, 2608, and there we are, 2608, right at that point. So the 2608, the next energy loss is 126, so subtract 126 from 2608, and that will be the start of the next energy. So here we are, starting, it's counting down. I got it in slow motion. Some of these will take a while, but 2481. So 2608 minus 126, 2481. It's going to go down. So it should stop after the bone, hitting the next flesh at 2481. It's going to be 2482 because it's 2481.6. They round up. So 2482. So 2482, it lost 83.2 joules. So 2481 at 83. So the next one should be 2398. So it's going to hit the next lung at 2398. 2398. And it's at the lung. The arrow's a little off on the right hand side. But in the lung, it lost 1,040 joules. So 2398, it lost 1040 joules. And then we're going to continue on. So that leaves it at 1358. We're going to go down to the next flesh. It's going to go down to 1358 right here. It lost 432 joules going through that flesh till it hits the next lung. So 1358 minus 432. This is from the in-game data. You can see it's the flesh. And I'll go over the other numbers later. So you can ignore those right now. Then we're going to track it down. So 925 is where it hits the next lung. So it creeps down. 925, bam, it's on the next lung. 925, it lost 737 joules in the next lung. That's important. Remember 737. So at that lung, it hit at 925, it lost 737 joules. Remember that number. We're going to go over it again. But that is not how much damage that lung took. So we're going to creep down from this lung. We're going to skip a bit. Go down. 187 is where the next one hits. Next flesh. It's counting down. Let's go into the next flesh. And it's going to be 188 because it's 187.5. We round up 0.5. It's going to be 188. 188. So 187.5, and it lost 30.0 joules in that flesh. So we will continue on from here. And the next one's going to be, it's going to hit the bone at 157. And it's going to lose 100 joules. So 157 hits 100 joules. That's going to leave 57. So here we go, hitting the bone. Now, we cruise on from the bone. 157.4 minus 100.25 is going to be 57.2. We're at 57 joules. And there we go. And the rest of it ended. So it lost all of its energy in that flesh. So that's going to end up to 0. That's going to be the exit energy. This is what we're going to look at. The M duration and the M start energy. This is how they make the graph. The duration is how long it spends in the lung in millionths of a second or microseconds, however you want to say it. They're both the same. And the M start energy is where it's starting and where it leaves the next organ, or where it starts at the next organ. So it's basically the energy loss. The start energy minus the energy loss is what's going to be the next organ. But what we care about is the start energy of each organ and the duration that it's in that organ. So I made the graph. These are all the same. If you want to go back and look at those things, they're all correct. So we're going to take the M duration right here. This is time, and the M start energy. That's the start energy of each organ, all the way down to the 57 from the 3046. So this is the cumulative duration chart. So what this chart does is we start at 0 at the 3046 because that's where the time started when it hit it. And then we take a cumulative of the time, the duration, for the next energy. So pretty much what we're going to do is take this duration. Well, that's the depth. So that's the depth that it goes into the organ. So that's how deep it goes, and this is the duration. So with the duration, we're taking pretty much each one of these times and we're adding it to the next time. Over there, I also have the 48 penetration and 48 cavity, and I'm just doing the energy loss times the 0.48 and the 0.52 to give the cavity and penetration damage. So the penetration damage is the same because that's a constant. Doesn't matter. The cavity damage is completely different, and that's how they do the damage bars. So, but damage given out in that total. So there's your total penetration, total cavity that matches the graph at the top, and your total hit energy is the 3046, which matches. So your total damage all the way down is 3046. So what we're going to show though is that the damage that's done on the graph is not actually the damage that's done in an organ. It can be less or it can be more. Penetration damage is always the same, but what you get in total damage is not. That's why I said keep track of that. The damage loss to 737 on the right lung, because the lung did not take 737 joules worth of damage. It took less than that. And the right lung, 1040, did not, took more. So here I'm taking the total damage of the organ because this is how they calculate it. They add all the flesh and all the bone. So I'm taking all the bone and all the flesh energy loss and adding it together. And there they are, the sum, J3 through J9 for the bone. That's the two bone organs. And here the J2, J4, J6, J8, and J10. That's all the flesh, adding up the total organ damages, and that's how they're going to do the penetration. So when they do the bar graph, they're just adding all those different hits that they did together for penetration. Cavity, completely different. So 226 on bone. And I know this is going to be boring for a lot of people, but so the lung, 1040.1 for the left lung, and the right lung, 737.8. And this is going to be the important one. So here we go with our depth and duration. So we got our M duration, time spent in the organ in milliseconds or microseconds, however you want to say it, and the M start energy. So this is where they're going to get the bar graph. That's all the bar graph shows. The bar graph shows the start energy, the next start energy, and the duration that is spent in that organ. So the first one we took 3046 and 0060. So here they are. That's where I'm getting them from. I'm getting them from those, what I took out of the game, sticking them in this Excel spreadsheet. So here is the Excel spreadsheet. So you see this graph. So this is the actual graph from the game. I did not edit that graph whatsoever. I did have to adjust the Excel graph to match it because it makes it whatever size it wants. But I moved it with the data to show that. So we'll move that out of the way. So this flesh right here that I'm pointing the arrow at, that should be down here. It should start one down. So that label is a little off. But here's your duration. So your duration, what I'm basically doing is taking the 000, because it's 0 seconds when it hit, And I'm going to the next one, and I'm taking the B24, which is the 000, and adding the B2, which is the 0.00060. And when you add that, that's going to be the next one, which is going to be 0.000069. So, and then you add that one, so the B23, which is the 00060, plus the B3, which is the 069, and then the B22, which is the 0069, and you're adding it to the B4, which is the 006, and you get 75. And we're going to continue to do that. So basically, that's what cumulative means. You're just adding the next one to the next one, and you're getting it all the way up. And we're going to do that to the last one, which would have been the exit of the flesh. So this is just your start energy. You see it, the 3046, that's going to be your start energy. That's basically D2. These are all coming from the tables that I put in from that chart. So going down to, all the way from D10, from D2 to D10, all the way down. But we're going to have one extra because we're going to go to 0 because that's where the game ends, at 0, because it ended inside the organ. So there's the 0. All right, so I clicked on the graph, and that's showing that this graph is actually made from this data. So if you know anything about Excel, just click on the graph. It highlights what this data is taken from. There's my points. So 000 in the 0060 at 2608 energy. We'll go to the next one, 0069 at 2481 energy. 0075 at 2398 energy. We'll move to the next point. That point is tracking at 00294 at 1358 energy. The next point is going at the 000403 at 925.3. So I'm just going through each one of these points to show you that this data is taking from the game. So 000809 at 187. 00829 at 157, 000871 at 57, and it ends with a time of 00967 at 0 energy. That's the very last point. Now, when we move the graph back over, you can see this lines up exactly. So I have all the points listed in the graph from the game and put into from the bar graph of the game into the data from the game. So the bar graph is energy loss over its duration, time spent in the organ. The only calculation of damage is penetration because it's a constant based on the bullet size, but cavity is based on energy dispersed over that time. So this is the next one. So this is where we're going to get the actual damage. So this is a lot. This tells a lot about the damage, the shot, the animal, the ammo type, if you're using a scope. But what we're going to zoom up and talk is about damage type. So you can see where damage type has got organ flesh penetration energy 499.940918, and cavity is 109.738. Can't see the rest of it, but I'll keep moving over. That's where the cavity energy 109.738869, penetration kill, cavity kill percentage. This is what we're going to go over. This is what makes the bar, the cavity kill percentage. And then the adjusted penetration energy is basically if you hit the animal a couple times. So I copied and pasted that because you can't scroll over, but you can right mouse click on it, copy it, and I pasted it to a Word document. So we got your flesh, and that's your penetration organ, which we remember was 499.940918, and your cavity, which was 109.738869, and then you got your adjusted and your cavity kill percentage on each one. Then the only other organ is bone. So flesh and bone are added up. Even though it hit multiple organs, they're added into the kill. And then your lung is a single organ, and each lung's a single organ, so it's got its own. So this is how we get it. So here's the bar. So these are the bars. I basically cut them off, kept them all the same size. These are just a picture of the organ bars cut. So you got your penetration energy and your cavity energy. That's coming from that chart. And you got your total damage for the organ. So this is the total damage. So if you see, the left lung actually took a total of 1783 damage, but the graph only showed 1040. So when you see that graph and you calculate that from organ to organ, it shows 1040. That's not how much actual damage it was. So this one's where I said 737. I'll get back to it, I think. So 737, that's what the bar graph shows, but the actual damage to that was only 356 joules. So that's why I always said, I don't understand, this can't be right. You take your right lung, it shows it's supposed to be, it shows 737 damage and it's 600 to kill it. It's because it only took 356. It's got 737 in there because it all depends on energy. So here's your kill percentage. So this number with your kill percentage, move the decimal 2 places to the right, you got your percentage. All right, so right here, 1.8290%. That's for the cavity kill percentage of flesh. And it was 8.3. So if you move over here, all they're doing is taking the B2, which is the cavity kill energy, and you're dividing it by 600 because that's what the lung is for the, what it is for the lung. So I'm going to format the cell to show you that all I did was just change that number to a percentage. And I did it to the 4 decimals is what the game does. So you click on here, that's the number I just pasted from the game. This right here is the numbers in. And here is where I did the calculation. So B2, which is basically the energy, divided by 6,000 because that's what it is for the flesh. So the flesh is 6,000 to kill it. So I just take B2, which is the penetration energy in the 6,000, and then I do the cavity energy in the 6,000. The lung is 600, so B4. Take the penetration energy, that's your kill percentage for penetration, and then I do the C4, which is the cavity energy, which is the kill percentage divided by 600, or the cavity energy divided by 600, which makes the kill percentage. So it was 2.14, and if you look over at the cavity kill percentage, it's going to be 214%. So that lung took 83% kill damage of penetration, but 214% of it was killed with cavity. So there's the 59%. And again, I apologize because I had to lose everything. So here's the chart. I clicked on the chart to show this is where I'm getting the data from, this kill percentage. I'm lining up the 100% mark because the bars are 0 to 100%. They're not joules, they're actually 0 to 100%. You can count them as joules, doesn't matter, as long as you do the right numbers. But I line them up for that. So if you look at the value, right there, 3.152%, 3.152 or 1252%. And the bars line up exactly. So here I take the 8.32% or the 8.32%. I clicked on the wrong one there. And then here's the 83.21% and 83.21%. And you notice the bars and the graph line up exactly. This is the 214%. So this is how much over it went from what you see to the cavity damage. Now, if it would have went to the max kill, which I think is 9,000 on the, or no, I can't remember what it is on the lung, 2,500, it would have done it. So the 1783 and the 1040, 1783 is what actually got put into the lung, 1040 is what shows on the lung. The right lung shows it actually took 356 damage. That's all it took. But if you look at the bar, the graph shows 737 joules lost in that lung. But it actually only took 356 joules of damage. And that's why I kind of say you can't really rely on the graph for damage. Because penetration damage, yes, but penetration rarely kills. Usually it's cavity. But all I'm trying to do is say the bullet design makes the difference. So that's all I've got. I hope you like it. Subscribe. Thanks for watching. And I'm going to do the cavity damage next.